contour or topo contour.
Oh, okay.
Do you see it?
Gotcha. I'm going to it.
Okay. And then see if you, the ones that are in it, see if you can see my screen.
Yeah.
Okay. So I just want to work this one in a separate,
These computers having problems?
that one did to the left. I don't know what happened, but I saw it on there. I saw it on there yet today, that one right there. So I tried to reset it. Did it reset?
It's just continually reset itself.
Okay, so I did see that. I need to I guess I need to turn it in.
I was thinking going to Jersey Mike's last week.
So I'm gonna copy
I'm down for
this,
anything. I'm curious.
put this in.
I don't even stuff like that.
Do you like soaps? Rachel? No way.
So if you want to get some graph paper out
Okay.
and kind of draw this one up, it'll be a good example.
Do you have any
Or
graph paper?
contours?
Yes, I must have said it over there, look over there, because I moved stuff around because I had some.
Yes, I got you.
Yeah, we used it last Thursday, we used it last Wednesday.
Yeah, last one's due.
You see some?
Use some.
They had 2 pads, they probably got stuff underneath here, they did.
Oh. Oh, what?
Yeah, I put something on top of it, that's why.
So contours, that's like, let me know what you did last week.
Yes, but you know how we've been doing contour stuff in chapter 26? Leave it up here. And contours where they connect equal elevations. So we're trying to, we did it in survey 1.
Okay.
So what we're gonna do is try to find out, because the contours, I showed them how it went in CAD and it connected really cool. So there isn't a distance, it didn't give me a distance on here. I guess you could say this is maybe a 50 by 50. But I went like you want to leave room, some height would on yours, leave them in a little more room because I only left 2 for mine. The X's are where the elevations are, is where they took a shot on the ground. Usually if we do this with GPS, it'll give me an X, Y, and Z. And you saw where the guy had been trying to set up a grid just like that, and we were getting shots. And then now we want to connect equal elevations. So you want to draw contours. You need contours for your maps to be able to find out what the existing ground is ahead of time. To be able to know how much cutter fill that you need. Kind of could be like a bar pit, but this time you've got elevations. Instead of doing a measure down, you've got an elevation. So we want to start, so I want to draw 2-foot contours.
So let's sketch that.
Yeah, you can sketch that on graph paper.
The contours ain't too bad.
And so,
Oh, yeah.
we go over this gets covered again in Topo and Site. So that's where, I think Zach said he's been introduced to it before.
Yeah.
And I'm just putting some dimensions. You don't have to have the dimensions. I'm going to put a few on just to give you an idea. I'm going to do my contours. So we need 2-foot contours. When you do 2-foot contours, you start with even numbers. So typically, when we're doing plans for PwC, we need 2-foot contours. If it's really flat, we could do 1-foot contours. So when we're doing a subdivision or subdivision planning class, which is actually a geomatics class, but it's a major elective for civil,
right.
We will do 1-foot contours because it's really flat. So it just depends on what the requirements are. You want to label every 5th one. You don't want to label every single contour because it gets really messy.
So we see, is that what these are? Are these contours?
No, we haven't got the contours yet. So we just got an elevation at each of these points. You know how you got elevations on the nails or around here?
Right.
It's like an elevation.
Okay.
So I want to start if I start here, what's the next even number after 707.4?
708.
708. So I'm gonna do 708. So I know we have a 708 and a 710, and that we're gonna fall in between there.
Gotcha.
Do you agree with that?
Yes.
And then on this one, I have a 708, a 710, and a 712, because this X, red X, the X is where the elevation actually was. So if I started with 8, it's just gonna do just like that. Ain't much to it. It's gonna come off one side and turn around there. Contours don't just dead end. Normally they're gonna go off somewhere else. But when we're just doing a square grid of it, it looks like it kind of goes off because we're stopping at the edge.
It's not pretty.
Now I'm gonna do the 710, since that's one of those major contours. It's an even. I'm gonna do it in pink. So for 710, it's going to do just like that. So you either want to darken that one in, and I would put 710. Now I'm going back, and I've got to get 712. Well, I know that this is 711.7, that 712 has to be somewhere in here. And we have a 712 and a 714 in between these two lines. And there's a 711, there's 713, so I've got a 712 about halfway. So these are just eyeballed. You're not going to sit there and try to interpolate
So I
in
guess-
between these.
So I guess these really aren't the exact. Or
They're
really
pretty close.
approximately.
So if I would do it in CAD, I mean, I've done it in CAD and then put it underneath my drawing. It's just kind of learning how to connect equal elevations. You're trying to figure out where exactly 712 would go.
So the grid lines are like the basic numbers, and we're just trying to guess where
Good.
these contour lines
Would
connect
be.
to their proper number.
Yes.
It's just essentially, it, like, we have to have it in terms of just where it would be. No, it's not gonna be 101, like, as long as it's below the certain numbers, it's good.
So we're trying to figure out on the map where the contours would be drawn if they were equal elevations. So I'm looking at the X's, what the elevation is at those grid boxes, and figuring out what contours would go through them, and then trying to kind of, you notice I'm starting like with the left, and then I'll kind of see where the next one goes through. Somebody piped and put something online.
Oh, no, it's just that, I think you always.
I start on the right, but you can start
You start from
either
anywhere?
side.
Okay.
You don't want to start in the middle.
Okay.
You can start at the top, or you can start. You can start at the left. You can start right. I always start at the right because usually
The right's usually where, I mean,
particular
Makes
one.
sense.
the right on most examples usually is the smallest and then it goes to biggest. Now, it would be different if you're doing a bigger contour, but like, this is just an example.
That makes sense. If
But
we-
you can go left or right. But you want to start either at the lowest point, which
Right.
was 708, or the highest point, which is 736.
So if we start. at
We
the
actually
middle-
have a 743, so it's really high right through there.
So if we start at the middle, is that technically wrong?
Yeah, you're gonna mess yourself up.
That makes sense.
We don't want to mess yourself up. All right, I'm not gonna label 708, but I'm gonna label 710 because I'm gonna label every fifth one. Now I'm at I just finished 712. Now I'm gonna go to 714.
14.3.
So the rule is do it every other even number.
Yes, 2-foot contours. So 2, 4, 6, 8, 10. Make your 10 darker, and then 2, 4, 6, 8. So you only want to label every fifth one because it gets too busy if you label all of them, and it's unnecessary.
So you want to do every 2 feet, so an even number, and then you label the fifth of each.
Yeah.
So like the tens and the fives.
10s to 20, so there's not gonna be any 5s for this
Tens
one.
and 20s.
Yeah, it'd be a 7, 10, every fifth one you would label.
Gotcha. Okay, short.
The rule would be fifth, and we'll kind of go over some of the rules
Perfect.
in just a little bit. I'm kind of jumping ahead because I want to make some are ready to go ahead and do this one or do this example. All right, so I've got 714. So I'm looking along the bottom between B and C. I see that the left is 712 and the B is 718. So that means I've got a 714, a 16, and an 18 that goes through there. Really looking at the 14. And this one's 712 and that one's 714. So 714 crosses somewhere here. And between this 2, which is 713 2, and the one that's got the X 711 717.42, I've got a 14 and a 16 in there. And then it's got to come out between 2 and 3. So if it's 713, you have a 14, 16, and an 18. So I'm going to kind of go, there's my 14, comes like that.
Let's see, would you say overall, is it hard pinpointing where like where you're trying to get like your numbers, like your 16 and 15 on the side?
I'm labeling it just for a minute, even though what. No, it's just like if you'll mark it on the little squares, if you'll mark where it comes through on the little squares, it's easier than to trace it.
Oh, okay.
So now I'm at 716, and if I know it's got to go between here now.
Right.
Because 722 and 714, now we've got a 716, 18, 20, and 22 between these two. If that's 714.3 and that's 722.5, I know that for even stations, I've got a 16, 716, 718, 720, and 722. Okay. Now between 714 and 73, I only have one 716. 716.
Specific dash marks between each box?
I do,
Like 4 or 5?
just so I can see where they connect.
That's just if you want a visual, like.
If you want a little bit.
Free flow, because I know where they go.
I normally, I'm not sure, so I kind of look, okay, between 714 and 73, I know I've got to have a 714. Okay, so now I'm here, I'm here, I'm here, and goes out.
Oh, because of the evens?
Yeah, so that was 716,
Right, because we're going 2 each.
doing 2 each. So now I've started my 718 right down here,
And I remember,
but I don't know where it goes next.
remember you saying, let's see, that you said they can't intersect,
They can't cross.
they can't cross.
Yeah, so if you'll notice, I'm looking for 718 now. Where do you think, you know it doesn't cross here because that's, so it's got to go straight up. Correct. So that would be, there's 18 there. We have a 20, a 22, a 24, and a 26 all in this little area. Because it's 7, so much drop, it's 10 feet. So I should have 5 contours. So I'm just looking at what these elevations are. So it's got to be an 18, a 20, a 22, 24, 26. Okay, so that comes through here. And then this is 717, and that's 727.3. So you know you got 5 in here as well. So you've got a 18, 20, 22, 24, 26. So it kind of comes like that, and then it comes out. Now I'm at,
Go across the 3.
Yeah, it's right below there because that's 718. So now I just kind of label, now I'm going to look at, if I want to start down here and look at the 720. Okay, 720. So between 718 and 718.3 and 726.7, I've got a 720, 22, 24, 26, 20. So between 718 and 722, I have a 20 and a 22. I'm getting kind of, so I'm going to go from here to here to here.
So you're doing
to 20 now.
720, okay.
To there, and now I got to figure out where it comes out at. So it's got to come out between the 3, which is 718.3 and 727.3. So I've got a 720, 22, 24, 26. And I should have done that one in purple. So I'm going over it with purple because this one should have been in purple because it's the every 10th one.
Oh, okay, so the every 10th one is supposed to be?
Yeah, or every 5th one. So you're even, so 720. So you notice I made 710 purple and 720 purple. We're almost there. All right, looks like I've kind of got the next one, 724. Looks like I started that one down here, 724 to 724. Comes up here. I was doing the lines, I kind of already had that one worked out.
Zach said it was 7 and no, Steve said it was 722.
722, yeah, sorry, I jumped over one. Okay, that was 722. 724 is going to be this line. Okay. 722, there's a 724 and a 26 in here. So it comes like that, and it comes out. 724, that was 724. Now I'm going to go to 726. Okay, now I got to do some more lines because I don't have any. So that's 726. And that, so it's got to come in between the A and the 731 is where I need to start at. So that's 726. You have a 728 and a 730. In between here, it doesn't even go there because that's 7.
28 in between the 26 and the 29.
A 28.
Right.
Yeah. Right here.
Vertical line, the vertical line.
So it goes here.
Right.
And then we got a 28 in here.
Right.
And this one has 10 again. So you're going to have a 28, 30, 32, 34, 36, because that's 37. Between 727 and 734, I've got a 28, 30, 32, 34. And in between 728 and 734, I'm going to have a 28, 30, 32. All right, let's see if I can do these together. There we go.
AI can solve this.
Oh yeah, you saw how quickly it
So
did
fast.
you saw how quickly I put those points in CAD and it
Right,
made the
right.
contours. But just learning how they hand do it is the practice. Okay, now next one's purple. Okay. Well, it's got to be right in here. Okay, I didn't do all these. I'm gonna do these in green for a minute. I got a 7, 30, 32, 34, 36. Let's go back to my purple. Okay. I'm going to do 32 next. 732. Okay, where's it going to come out at?
So, let's see, if you don't mind me asking,
Mhm.
is this particular one, like, is this one for a mountain, or is this like some type of pit? Or
I don't.
what do you think?
It looks like maybe just a job site.
That's a job site?
Yeah.
Oh, okay.
It looks like a typical job site.
Gotcha.
All right, so I know that this is 731 and this is 735, so I'm going to have a 732 and a 734. So my 732 is going to come out. I'm going to do 734. 4 comes up, comes up, and comes out. Seven 36 is right in here. 736 is somewhere right in here, so it kind of comes out, comes around, comes up, and 736, you're going to have a 36, 38, 40, 42. Something like that. So that's my 30.
So I'm gonna come mighty close to each other.
Yeah, they are. You got to get, like, see how many you got in here. So I'm looking at 738 next. So this has got a 38 and a 40 and a 42. This has a 38, a 40, and a 42. So this is the 38. Next one should be our 40. And the last one would be 742. Now, you would want to label that top one just because you wouldn't know if this is 740. You would assume this was 740. Well, you would because the X. The X tells me that it's 742. But if you didn't have spot elevations, you would want to label that one just so because it's your last one, and it could go up or down. You don't know, not sure. All right, so saving, save, and exit. Save it as the same file. Oh no, crap.
The sound of defeat.
Yeah. I didn't want to write over I wanted the original one there. And let's see, okay, I wanted the original one.
But
I mean,
why are you drawing all these lines anyway?
for contours.
It's a thing.
Is it like a problem?
It's not, well, yeah, it's definitely false.
That's it. That's it.
That's it.
That's not.
That's
No
what
math, no
definitely
computation. just
Nope.
No, it's
figure it
literally
out.
just making
Yeah.
sure you know where to go. That's what
It's kind of learning, like, if the computer makes a mistake, you can kind of
Definitely want to
see.
get some more practice on them. At least for me. personally.
So yeah, it was
It's really
just,
easy.
because we've been talking
Like,
about contours, we just didn't,
hang of it,
you're learning how CAD's gonna interpolate them. You're
Right.
gonna see, but they're gonna interpolate in between.
So I guess we're learning how to interpolate them with how.
Yeah, but we're just kind of eyeballing them, and that's what they'll call it.
Sure.
Let me make sure I didn't, see if I have my original one first. I was trying not to override, that way the next year I have a,
then, I don't know if you knew that sort of set broke another second. And so I forgot what it was for.
Oh, so I do have the original one, good. I'm gonna do this as a PDF now.
Yeah. Or PDFs. When it normally comes to assignments on Google, are we allowed to do assignments on Google, like on Google Docs, or the school doesn't really use Google like that?
As long as you can convert it over where I can read it,
Oh, okay.
I
Gotcha.
don't care how you do it, as long as I can read it, you know, as long as you can do it, I don't really care.
Download
Makes
as
sense.
a Microsoft Word, and it would mostly convert 100% right.
Well, okay. Yeah.
And even if some computers don't have Microsoft Word on them, if you download a file as a Microsoft Word, it'll open like a sheet that is similar to Word, so you can edit any mistakes that you have.
I forgot how to do it.
Okay, so this is from Topo Inside, I kind of picked it up, because it was on here, it looks like it came in from his land surveyor's reference manual.
Depression.
Yeah, that means there's a hole, means it's going down. A saddle means like these two have the same, probably something have the same elevation, kind of like here.
Gotcha.
A summit would be a top point, like this would be, looks like it's 650, and this would be, it depends on if these are 5 foot or 10 foot contours.
These are
Looks like-
10-foot contours.
Looks like they're 10, because that's 700.
Oh, yeah, 10 foot, and then it's 50 for labels, yeah.
So these are 50 feet long?
These are 10 foot.
Oh, 10
So
foot.
like that's
That's
7,
50 labels.
that's 700, 710, 720, 730, 740, 750. And then this is a high point, they call that a summit.
California.
Belmont.
And then saddle, summit means a high point. A depression means a low point. If there's, the V points means it's a stream, and the tips of the V means that's pointing upstream.
Gotcha. How about a ridge? Is a ridge like just, there's a ridge.
There's one right there. Oh,
Now
kind
it's
of
like a
like a
bunch of-
ridge, viewpoints downhill.
Is that like a slope? Whoa.
Did like,
So these that are evenly, see how these are evenly? That means that's pretty even land.
Right.
If you get them closer together, that means it's pretty steep.
Uniformly
They're
spaced
like
The
contours?
flatter they are, then the more level it is. The closer they are, that means that is steep.
now if it's like a cliffside, there'd be like a bunch of lines right on top of one another.
So architecture one year had, had a map, kind of like the one I just did the PDF, this one. But they had where one of these had 100 in there.
Oh, wow, 100.
Yes,
What, like
Yes.
100 of those lines?
yes.
No way.
And then told them to draw, they said it spent them 2 hours just doing one little,
Why'd they make them suffer like
I
that?
don't know.
Just for the cat.
I don't know who assigned it, but I said,
They
that's
didn't
just
like
not
them.
practical.
Like them.
Because they're like, how are you supposed to do it? I was like, that's just not even practical to give y'all an example like that and expect you to draw 100 teeny lines in one little block. And the block wasn't no bigger than this. All right, so that's what it looks like, a contour. You're just doing, basically by eyeball, you're trying to do a contour. This came out of your textbook. So I'm gonna show you where it came out of your textbook, but I did it every 2 feet and the book did it every 5 feet. So with that said, I am going to show you in the book where it is, and then we're gonna I'm gonna go back to the other collaborate section and close this one.
Are you guys normally coding here, like in like the ATC building in general? Or
No,
this
I was
is-
kinda hot earlier. Why, are you cold now?
A little bit. I like normally this class I don't get cold.
It just been, if I came in here after the night, they turn it way down to like 60 something normally. And so you can change it by 10 degrees. Was it you that was in, y'all were doing your CAD when it was so hot in Mr. Villa Mills?
Oh yeah, facts. They have the windows up.
And it was so funny because he was asking them, they're like, well, it says it's 70 degrees. He said, what, 70 degrees Celsius?
Right.
Right there it is. But they did every 5 feet. So there's the same example I did. I just put some numbers with it, but they did it every 5. They did 710, 715, 720, 725, 730, 735, and 740.
That's much.
Rachel gets the clock.
I did 2 foot. The reason I didn't do a 5 foot is because usually for any of our plans in Cumberland County, it has to be 2 and 10. So it has to be 2 foot. And 1 foot if it's needed, if it's flat, but they're not gonna let us go every 5.
That's because the land's flatter over here.
Yes,
That's
that's true, because if you're in the mountains and you're trying to draw this in, it'd be squunched together.
That's very true.
So this example is part of, chapter 17, so I'm gonna give you kind of the introduction to it in just a minute. So I'm gonna go ahead and log out of this Blackboard, on this Collaborate. That way it'll save and close.